So, my project is a solution for one of the robotic competitions. As you know, there are various robotic competitions in the world, and all of them are aimed for educating people and for more people to join the robotics field. And one of the competitions is World Skills. It's a world competition that covers different skills from aircrafting to building and a lot of different fields. And one of their field is mobile robotics. This competition takes part every 2 years in different countries, and this autumn it takes part in Abu Dhabi. And I prepared a robotic vision solution for half of that problem. The problem calls playground monitoring. It's about kids having fun on the playground, and parents they want to monitor them, but a robotic solution to watch the kids. And the sand in the middle is a place where kids would have fun, and on the left side there are some barcodes which indicate parents, and there is correspondence between the barcodes and the kids, so you need to gather all the kids around the field and bring them to parents. As you see, vision performance capability, the robot should be able to recognize the barcodes and the balls, and that part of vision I prepared. As a rules, you need to use MyRio embedded system. It's a real-time embedded system which is done by National Instruments. You can see some specs on the right. It's a bit overpriced, but has an interesting performance due to combining ARM processor and FPGA board on the one board. And the programming is done in the LabVIEW. It's graphical computer language, and MyRio is only compatible with the LabVIEW. So let me show you my solution, how does it work and how I came up with it. So what I started with was only this picture from the presentation where I have barcodes and the balls. Next, I tried to cut the templates from this image, and the first thing that comes in mind, oh, I have these templates and I have whole image, I can try pattern matching. And in my project, LabVIEW is cross-platform, so it's same code for the PC and for the robot. So first thing I tried is, you can see that fine pattern matching successfully confines templates in the whole image, but it has two main issues. First of them, it cannot scale them. The scaling is allowed for plus minus few percents. That's why if you change resolution or you move objects far away from the camera, it will not be able to recognize them. Occlusion and rotating is fine. Another problem is performance. Pattern matching is not that fast, and it's not acceptable for the embedded system where efficiency should be very high. After this, I tried different programs, concluding geometrical pattern matching, shape matching, and other approaches, but all of them had same results. So I started to think, how can we solve it? I tried to go on a bit lower level of robotic vision, image processing, and on the whole image, do something as we do in April text, recognize squares and compare them to the templates. First, I convert my templates, I improved contrast so we can see them, and then I moved them to the binary. So now they are just 9 pixels per 9 pixels, small binary images. But when we run it on the embedded system, performance is still not enough, as when there are binary images, they use image buffer, which has restricted size. That's why my solution was, after reading them, store them as a bitmap in the system. After I read a binary image, I convert them to the array of booleans, and here you can see all of the templates stored already in the PC. So it would be easy to store them and faster to compare. And here's a whole program to recognize the patterns. Here I have some of them printed. I think contrast will allow them. When I show the picture, it can detect where it is, and on the up above there is a bool map of the template which looks like this object. I can even use 2 of them, and I can use as large amount as I want. Inside, that's the view part. On the up there is part for getting images. On the below, to the left, we read templates and store them as a Boolean map. And as a block inside, we have all the image processing. What do we do? After we recognize the shape, let me stop it. The best part of LabVIEW, it has really nice image processing blocks. It can be simple blocks and Vision Assistant. In Vision Assistant, actually, you can see result of your actions. If we open an image, an example, you can see what every step does. How do we threshold? For threshold, you can choose different the way how you want it, and you can change values and see directly what happens. So you can find the best for you. And the main part is here to detect squares, but shape detection is pretty heavy computation. It would take a lot of time. So my part was to filter all the objects that we don't need. First, we remove border objects. Obviously, there would be no squares on the border. Then I use erosion and dilation to remove some small objects and noise. Then, counting perimeter, I remove other small objects. Then fill holes. So on the left square, it wouldn't be detected as 2 squares, but as 1 big object. And then last filter calculates the bounding rectangle and checks whether the bounding rectangle is in the shape of the square. If it's a rectangle, as for a long object, then it would be just filtered. So we find the bounding rectangles. In the end, mostly we get only this kind of squares, sometimes other small objects. And shape detection, last function, as we don't have much object, most noise is filtered, can easily detect them. It sees the edge and finds 2 squares on the left and on the right. That's part for the Vision Assistant. And another good part of LabVIEW is when you see it online, you can use nice debug function. As an input, we see original image, and then we improve contrast and use median image to remove some, wrong button, to remove any noise. After that, the image is ready to process for rectangles. It's a binary image already. Zoom to fit. We can see a binary version of this rectangle. After that, we want to mark it with a pink frame to know where detected rectangle is. And in the end, we have this rectangle framed. Then we can extract it as a small part because we already know coordinates of the borders. So we extract small image in grayscale, which we can process to make more clear, move to binary. Move to binary. It already looks like our template. And then we convert it to our bool map, so it looks like this. It's already a value that is easy and fast to process, which is then compared to all the templates we read, and the one that is matched with the green frame. So we can see the template here, and the result is given to the outside program as a result of the object that we can see. And the thing is, to run it on the embedded system, I've done a lot of efficiency improvement. At first, one loop ran in 5 seconds before all the filtering, and it's not suitable for real time. After filtering, it was 0.4 seconds on embedded system, so it's more than 1000% improvement. So when you try to solve some task, it's always it's not easy to find the right approach. and you should try hard to find the efficient way to be able to run it. That's all. So it's vision part for that competition.